Good evening, my 11th standard warriors. It's time to open the doors, not literally, but we're going to discuss about torque and the physics behind opening of doors. And then we'll end the class with toppling. Why do vehicles topple? And we're going to calculate the speed at which a vehicle will topple, and it is amazing. So all of this with me, Shreyas, your physics master teacher at Vedantu, going live. I hope you're all excited for today's session. Hello Chitra, hello Saja, Ishpreet, Gokulnath, welcome aboard. And we have somebody new out here. His name is RCBN. Oh my god, a dedicated RCB follower. Hats off to you. Hello Harita, hello Dinesh. Welcome, thank you for all the love. Your Capto is back on screen. And this is lecture number 2 of Nurture series. The chapter name is Rotational Motion and Rigid Body Mechanics. We have spoken about moment of inertia in my previous class. Today it's time to go ahead. And those of you who do not know me, I'm Shreyas. I'm the physics master teacher. I did my graduation from NIT Nagpur. I did my research from IIT Bombay. I got almost full marks in physics when I wrote my JEE, and I have been training kids for more than a decade. So all of this experience, this knowledge, this hard work, this passion is just for you, so that you get benefited from my teachings no matter where you are sitting. So here I am on YouTube on JEE Enthuse, which is a dedicated English medium channel for all the students across the country and across the borders out there. So get in, join in, and if you haven't subscribed yet, go hit the subscribe button. And yes, as a token of love, do not forget to smash that like button out there. Okay, so some of you have the term 1 examination on November 23rd. Yeah, I'm pretty sure before that most of the chapters will be completed. And Chitra is all excited. Thank you, Asrar, Ashan. Glad you love my teaching. Hello, voice by Ram. What names you have? Crazy. Mohammed, go what your heart says. See, spend some time, maybe a week. Think what you like. Do you get fascinated by machines? Do you get fascinated by computers? Do you get fascinated by electronics? Do you get fascinated by something related to engineering or science? Or do you get fascinated by treating patients? Do you want to know about the human body or the animal body or maybe the plant kingdom? I don't know. So depending on that you decide, okay? But go where your heart says and let others not influence you. That's what I would say. Hello Palvin, hello Jai, good evening. Muskan, hello T Harshita, hi Dinesh, hello Sohail. Welcome aboard. Just in case, if you have your backlogs and if you need a mentor and you need assignments and test series and you need help from teachers like me and you want to study in the micro courses where I am teaching, you want help from teachers like us, and you want a dedicated study plan to cover your backlogs, and even if you have joined a coaching and you are not happy, you need that help. So I would suggest you guys to consider the Vedantu Pro subscription, which is like a one-stop dedicated solution for all your needs at very affordable prices. It's just like Amazon Prime, where you take the subscription and you can watch any number of movies free of cost. You don't have to go to a theater every now and then when a movie releases. Same way over here, this is a subscription plan which fits in, for all kinds of needs. It's one place, one roof where all the problems get solved. And the best part is these classes are live. You also get the recordings and you can watch the recordings as many number of times just at the comfort of your home. You don't have to travel anywhere. You're all safe. You save a lot of time. And yes, there are a lot of other benefits that you get when you learn online. So the course prices start as low as 1,350 rupees. There is a link in the description box below. There are different packages like Light, Classic and Plus. You can choose depending on what you need and what you don't need. Most of the students go for the classic version. Alright, so having said that, let's go ahead with force versus torque. But before that, let me quickly show you our talented warriors. So where are our talented warriors? They are always on the chat box like you guys. Like I can see Chandan, Karthik, RCBN. Oh my god, RCBN was watching my work power energy lectures. Glad you completed that, and right now you are here in the rotational mechanics. Well, and I'll show you where they are. So when you go to the videos, this was my last lecture, yesterday, lecture 1 of rotational mechanics. And I had asked you to solve a homework question. Every lecture I give 1 or 3 problems, as homework. And there we have Ishpreet, very good Ishpreet, very good Harita HB, very good Yash Garg, excellent Chandanam, very good Srasti. And am I taking any 11th standard long-term batches this year? Unfortunately, no. But teachers like me are teaching. Number 2, there are a lot of micro courses where I am conducting classes, and you can watch those recordings as well, like HC Verma, derivation micro course, problem solving micro course, all of them are there. Suchi Mama, very good Saja, Gokulnath, Dakshin, Paulami, and Jesus Sile. If I take 1 month pro subscription, can I watch your micro course? Yes, you can. Even if you take 1 month micro course, you can watch all the recordings, all the live classes till that 1 month. After that, it will not be available. So that's the meaning of 1 month subscription. Okay, excellent Gokulnath. Thank you for posting all the answers, and do not forget to post the answers after this as well for today's session. Let's get going, and if you have not yet smashed the like button, do that right now. Let's talk about torque and force. So, what does force do? Imagine you would have pushed some friend, you would have pulled some friend who is not ready to go out for a snack or for a party. You would have pulled a friend, you apply a force. So when you apply the force on the friend, when you pull that friend, yes, that friend changes his state of motion. He accelerates. So force causes acceleration. A force causes change in the state of translatory motion. So that's what a force does. You push a box, you pull a box, you lift a box, you lift a book, you drop something. So force always changes the state of translatory motion. A similar term is also there in rotation. Somebody is standing quiet like this. You just push him, you twist him, he starts rotating. That's rotational motion. You initiated rotation. You have applied force, but that force which causes rotation is called torque. That force effect which causes that rotation, the twisting effect, the twisting cause is basically called as torque. So you have a fan, or you have a wrench, or you have anything which can be twisted, rotated, or a wheel. Okay, you apply a force, that force causes the rotation. That combined cause which causes that rotation is basically called as torque. So torque basically changes the state of rotational motion. Like this Pandu out here, who is trying to rotate this screw using, this device, this lever. I hope this is clear. Yes. So torque is the cause which causes rotational motion. It's not the effect. There is a big difference between effect and cause. I hope you understand that. In case you don't understand it, let me explain over here. This is very, very fundamental. Not many students know about this. Not many coaching institutes teach that. See, what is it? Okay, let me get this gentleman out here. Let me just pause the screen as soon as, oh yes, he's here. So there is a force acting because of which this accelerate. And you have Newton's law which says F is equal to ma. This A is the effect and this F is the cause. Because there is a force, hence it accelerates. Because you pushed it, hence it moves. It's not the other way around. Because it is moving, it won't say, hey, come man, apply a force on me, I am moving. Nah, that's not what's going to happen. So always force comes first, hence it accelerates. Same way, it rotates because there is a torque. It's not the other way around. It's rotating, hey, come on, apply the torque. Nah, the torque is the cause. So understand that torque is basically the cause of the change in state of the rotational motion. State of the rotational motion. Is that clear? Do you understand the difference between cause and effect? Everybody give me a thumbs up. Excellent. Gokulnath says clear. Oh, Suchi also understood. Yes. Let's solve a question on doors. Let's solve a question on doors. And here it is. Where should the force be applied so as to open the door? Yes, exactly, Abhinavar. Force causes change in linear motion, torque causes change in rotational motion. Perfecto, you got it correct. Hello Aluka, Harshavardhan, good evening Bachalo, good evening my warriors. Oh, by the way, more than one options are correct. It's not one option, more than one may be correct. So term to Ishika, as soon as I complete rotation, I'll start term 2 as well, yeah, but this chapter is very important, you cannot ignore it. So let's do this in detail. Okay, Ishika? Hello Sundar, hello ideas. Okay, so now you started putting up more options. DC, BD, ABCDE. No, it's not ABCDE for sure. I'm very good, Srashti. I just took your name for solving the homework. I think you missed that part. Okay, so where should the force be applied to open the door? Okay, let me just do something. Let me just bring a book or something. You know, the most famous apparatus that I have is my scale and this book. Okay, so this is my door and it is hinged over here. You can see the knob is over here. There are two hinges. I don't know whether it's visible. Okay, so basically the door is hinged over here. Now first option A, says you apply the force on the hinge. So the door can open like this. If you apply the force here, how will the door open? Yeah, obviously, how can you pull a door or push a door using a force on the hinge? Doesn't make sense. So obviously A option is wrong. Do you guys get it? A option is obviously wrong. It's on the hinge. It's on the hinge or on the axis. It's obviously not allowed. B, yes. So you apply a force. That cross denotes it's inwards. That means it's inside. So a force acting like this. Yes, the door gets opened. You can see that it gets opened. You apply the force here, nothing happens. A force applied here obviously opens the door. Yes. Option C, what the heck are you doing? I mean, like, you're applying the force like this. How can this force open the door? Is that making sense? Is that making sense? This force, you cannot open the door. The door will come out. It will break. You will get a flying chappal from your mom for breaking the door. So do not open the door by pulling it down. Yes, so C is obviously wrong. You are going to get a flying chappal for breaking the door. Okay, so you're going to get a flying chappal for breaking the door. Okay, great. So what about D option? D option says you are applying the force here. Yeah, I think that's fine. You can apply the force here. The door obviously will get opened. So yes, D option is correct. What about option E? Option E also doesn't make sense. I mean, come on, think about it. You are pulling the door. You're pulling the door. This is the hinge. You're pulling the door like this. Again, the same thing is going to happen here. You're going to get a flying chappal for breaking the door because you're going to pull the door like this. You're not opening the door. Technically, you have opened the door permanently, not temporarily. So that is not counted. I hope that makes sense. And what is chappal? Chappal is, I wish I could show it. It's not there in my room. So chappal is this, slippers. Okay, this is slippers. Okay, beautiful slippers. Is this how slippers look like? That's how my slippers look like. Okay, yeah, that's a beautiful drawing of slippers. So chappal is slippers. Yeah. Okay. Great. Let's get going. Okay. Okay. Yeah. Let's get going to the next concept. So B and D were the correct answers. Now, here is the thing. This diagram, this simulation gives you a beautiful feeling of what torque is. Look at this particular, animation where this guy is trying to rotate this screw. It's very difficult if you try to rotate this nut or the screw using your hand. You find it difficult. But the moment you use this spanner, you fit that spanner on that bolt and you try to rotate it, it suddenly becomes easier. If you have a longer spanner, it becomes even more easier. You would have experienced this especially if you're trying to replace the wheel of your car. How many of you students have tried helping your dad or maybe somebody helping them replace the tire of a car because it got punctured, or maybe the scooter? They would have asked you to stand on that spanner and you would have jumped on it because you want to rotate or tighten or loosen that nut. Have you tried that? Have you tried that ever? Maybe you Harita has tried it. Yeah, they make use of all the kids, child labor. Yeah, so all of you have done this kind of child labor where you have stood on that spanner or you have removed that nut or tightened that nut by applying that force. So that force has created a torque. So understand what torque is. Torque is that rotational cause, is the cause for that rotation, and the longer the arm, longer the length at which you apply the force, the more easy it is to rotate it. Just like when you have to open the door, you always try to push as far as possible from the axis of the door. Whenever you have to rotate this or rotate anything, you try to push as far as possible from the axis about which it is rotating. That means the torque is more when the distance at which you apply the force is more. Is that making sense? Is that making sense? Yep. Jumped in a lorry tire, and many of you have done it. I can see a lot of you people have raised your hands, and some of you said no. Okay, maybe you should try it next time. So let's get to the definition of torque. Imagine R is nothing but the distance from the axis where the force F is applied. The force F is applied, and this force F makes an angle theta. So I'm just going to call this angle over here as theta. So this is the axis, basically. You can see this is the axis. This is R, this is F. R and F make an angle theta. You can see that. So theta is the angle between R and F vector. Lot of people think R is the radius. Those of you who have learned R is radius, please flush it away. R is not the radius. R is the position vector or the distance vector from the axis to the point of application of force. It's not the radius. Please flush it away. Okay. Now, if you notice, this force can be split into two components. One is F cos theta. The second one is F sin theta. Tell me which component is responsible for rotating this object about this axis. Which component do you think is responsible for rotating this object about this axis? Is it F cos theta? Will F cos theta rotate it, or will F sin theta rotate it? Think about it. Excellent, Eroji. Excellent, Harshini. No Dakshin. Think, what will F cos theta do? F cos theta will pull this object like that. It will not help in the rotation anti or clockwise. It will not help in the rotation. So F sin theta is basically creating the torque. F cos theta is useless. It's unnecessary. It's a waste component of that force. It is not at all required. In fact, if the entire force was here, it would be much better, because then there will be no waste component lying out there. So in order to generate the maximum torque, one would obviously take this force and apply it in this direction so that the torque is maximum. Is that making sense? Now, the torque is basically proportional to this R and F sin theta. So torque is proportional to R. Why is it proportional to R? More the R, more the torque, more the rotational cause. More the F sin theta component, more is the torque. Again, because this force component is larger, the torque, the twisting cause will be higher. So it's proportional to R as well as F sin theta. Now the symbol for torque is this symbol, Greek symbol tau. It's called as TAU. That's how you pronounce it, rather, tau. So it's tau. Okay. So this tau is replacing the proportionality constant R F sin theta. In case you are wondering what happened to that proportionality constant, this is 1. So this is constant of proportionality, and that is because for 1 Newton meter, you can see meter and Newton, torque is produced when R is 1 meter, F is 1 Newton, and theta is 90 degrees. Basically, sin theta will become 1. So that's why that constant of proportionality becomes 1. So you define the unit. The torque is 1 Newton meter when R is 1, F is 1, sin theta is 1. So that constant also becomes 1. That's how it is. Now, like you can see, R is a vector, F is a vector. I think you should have immediately understood that the moment you saw sin theta back from the chapter of vectors, Yeah, it's got to do with cross product. So yes, torque is the cross product of R vector and F vector, but I'm not sure should I put F first or should I put R first. Let's get to it logically. Let's not by heart it. See, just look at this. This force will try to rotate this body in clockwise direction or anti-clockwise direction. Put it up in the chat box, my warriors. Okay, many of you have started answering it. By the way, I can see many of you have already studied this. Very good. Will it rotate in clockwise or anti-clockwise? Obviously anti-clockwise. Excellent. So it will rotate in anti-clockwise direction. So this is anti-clockwise direction of torque. Now, you never show vectors as a curved line. You always use right hand rule, correct? So if anything rotates clockwise or anti-clockwise, always curl your fingers. You can see curl your fingers in that direction. The thumb represents the direction of the torque. So the torque is basically towards you. So this is the direction of the torque. Now you'll be like, sir, torque is coming towards me. What is coming towards me? Nothing is coming towards you. See, when I say the torque is this way, all it means is hold your thumb in that direction. Automatically, your fingers will curl like this. The meaning of that is the torque is trying to twist it like that. So wherever the torque is, hold your thumb. It's just a representation of what the direction of the thumb should be so that you can curl your fingers to predict the direction of rotation. Is that clear? So nothing actually comes over here. It's just a representation. If you hold your thumb, the fingers curl this way. So it's understood that yes, the body is rotating like that. Now think, by definition, F cross R. If I do F cross R, this is F, this is R. F cross R, F cross R will go inside. No, not done. But if I do R cross F, R is there, F is here. R cross F, you will get it outside. Hence, it is R cross F. Is that clear, my warriors? Yep. Is that clear? Thank you, Ram Kailash PN. Glad to know that. Yep. So that's what happens. So it is R cross F because the way we defined the cross product to be. Yes, right hand thumb rule is very important. So all of this will come up in your notes. So when you download the PDF from our Telegram channel, in case you haven't joined it, you can join it even right now. It's there in the description box, the link for joining it. You'll get all the PDF of this. Okay. So the torque is also known as the moment of force. So some places they refer to torque as moment of force. Don't think, sir, what is moment of force? You didn't teach it. Guys, it's the same thing. Just like you have different names, right? At home you are being called as Chintu or Bablu or something else. So same way, torque has its nickname. So what's the nickname of torque? It is called moment of force. Okay. Now what is the meaning of net torque? Just like you have, yes, N is the unit vector, correct? Yes. It's like the vector which is along the direction of R cross F, that using right hand rule. Now the thing is, net force means the sum of all the forces. Net torque means the sum of all the torques. Why will I need net torque? Because on a body, there might not be just one force. Maybe there is a war between all the cousins in the room. One person is trying to pull the door, other person is trying to push the door, other Bunty is trying to pull it, other Pandu is trying to push it in different place, Champa is trying to pull it from the other side. Lot of crazy things can happen. So there could be multiple forces acting at multiple places. Each force will create a torque. So the total torque will be the sum of not all the forces. It will be the sum of all the torques. Keep this in mind. So the net torque is always the sum of all the torques about the given axis. What it means is the net torque is basically tau 1 plus tau 2 plus, there will be n terms like that, means it will be R1 cross F1 plus R2 cross F2 plus R3 cross F3 depending on the number of forces. Remember, you cannot accumulate all the forces at some random place. Each force will be applied at different places. So these R's are also different. Keep that in mind. Yep. Yes, sir. You are using proper North Indian nicknames. Oh yeah. I don't know. Different regions have different kinds of nicknames. You should tell me what are your nicknames. Everybody put down all your nicknames in the chat box. And if you don't have nicknames, make one. Okay. Chalo, let's solve this question. Good evening, Harish. Late joining. Gokul na Pavam. I'm just 15 years old. Oh my god. Pavam Bacha Chitra. Suchi's is Suchi. Gokul Nath is Gokul. Abhishek Reddy's is Kinnu. Wow, nice name. I like it. Raju Bhai. Kya baat hai Akash Raj. Raju Bhai. I like it. Raju Bhai. Dachu. Oh my god. Saja has Saj. And Dinesh Babu DB. Wow, that is nice. Sansu. My god, what a name. Sanskar has Sansu. That sounds Japanese. Mayank has Maya and Sundar has Aditya Verma. Oh my god. Sundar, your nickname is bigger than your name. Are you sure that's your nickname? Okay. Chandan has Chand. Wow. Eid ka Chand, like, okay. Tanjore, Shakti, Rosh, Ashu. My friends call me Chabli. Oh my god. Bot. Madan has nickname Bot. Man, that's crazy. Look at your nicknames. That's crazy. Rosh, Ashu, Sai. Okay. So, who's that? Somebody's nickname is R cross F. Oh, you're mentioning the problem. Oh, I'm so sorry. Subranshu Shekhar Sarangi. I thought your nickname was R cross F. Okay, Harita. My nickname is Capto. Yeah, Capto Shreyas. Yeah, that's what it is. Okay. So, find the torque of the force about this point. The position vector is given. Come on, this is an easy one. You should be able to do it. Harish CR7. This reminds me of the son's name of Elon Musk. He named his son some crazy alpha numericals. It's crazy. Yeah, something like in Star Wars, R2. And then the robot comes, yeah, from wherever it is. Okay, so R cross F, that's the torque. Let's do this. And I had taught you a short trick of doing it. Okay, so let's do this. Okay, so what you need to do, first write down I cap, then let me just write it here, I cap, then put minus j cap, and then put k cap. R, so put the coefficients of each component. So 2, 3, minus 1. Then F, put the coefficients 1, 2, minus 3. And then below you put I cap, put a bracket, then minus j cap, put a bracket, and then k cap, put a bracket. Now it's just about ignoring certain rows and columns for each of these brackets. So for I cap, ignore this column and ignore this row. You can see 3 minus 3 minus 1 2 3. So always go like that. Always go like this. This is the manner in which you should go. So 3 into minus 3 is minus 9. Minus 1 into 2 minus 2, but minus of that. So that's what it is. So this into this minus this into this. Next, hide this column, hide that row. 2 into minus 3 minus 6 minus. Minus 1 into 1 minus 1. Great. Last, hide this column, hide this row. So you are going to see 2 into 2 is 4 minus 3 into 1 is 3. Yep. So what are you going to get? Minus minus plus. So minus 9 plus 2 is minus 7 I cap. Minus 6 plus 1 is minus 5 minus minus plus. So plus 5 j cap. 4 minus 3 is just 1. So plus k cap. Newton meter. So that's the value of the torque. That's it. Done, done. Very good. Yeah, it's just like determinants. Exactly. So if you are well versed with determinants, I'm pretty sure you can get this. Yeah. So not necessary to find the unit vector in the torque, Abhinav, unless it is asked. And you know how to find unit vector. Unit vector of torque will be nothing but the vector itself divided by the magnitude. So if somebody asks you to find the unit vector, then you will find it. But in physics, they will not ask you to find it, because then it will become more of a maths problem than a physics problem. Okay. And very good, Angel Nikki. Welcome aboard. Let's move on to the next question. Yes, that's the answer. And here we have the next question on your screen. So read the question carefully. It says there is a small ball of mass 1 kg, and then the question says that the length is 1 meter of the string. The other end of the string is hung at a point O. When the resulting pendulum is making 30 degrees with the vertical, what's the magnitude of the net torque about the point of suspension? So let's try to picturize it. What is it exactly? First of all, there is a point of suspension. That means there is a roof. Okay, this is the point of suspension O, and there is a thread, and this is your point mass over here, and that thread is making an angle of 30 degrees with the vertical. Just check this out. It is making 30 degrees with the vertical. The question is, what is the magnitude of the net torque? They have clearly asked the word net torque. So first of all, what are the different forces acting on that mass? Number one is obviously the weight. This is mg. The second force is obviously the tension. Now, the question says find the net torque about the point of suspension. Think about it. Which is the r vector? R vector is the position of the force. So technically speaking, this vector, which is directed from here to here, this is basically your r vector. Are you able to see that? Okay, can you see that? Now, here is the thing. If this is r vector and this is the tension vector, what is the angle between r vector and the tension vector? I think it is 180 degrees. Now, if it is 180 degrees, what will happen? Sine 180 will become 0. Hence, the torque of the tension will be 0. So let me write it very clearly over here. Torque of the tension will be R into tension into sine 180. And in case you have forgotten, sine 180 is 0. So the torque of the tension force is basically 0. Another way of looking at it is the tension force, when extended, passes through that point O itself. So the tension cannot create any rotation because it is passing through the axis when you extend it. So any force which passes through the axis when extended or contracted, that force will never ever create any torque. Yeah. So now the only force which is creating torque is mg. I think I can split mg into two components very easily. One component over here, the other component over here. This is 30 degrees. This is mg cos 30, and this is obviously mg sin 30. Which component is creating torque? Think about it. Is mg cos creating torque or mg sin creating torque? Mg cos is pulling that thread. It's stretching that thread, but it is not rotating it. The only component rotating is mg sin. So the torque of the weight will be R, which is L, into mg sin 30. That's it. I have already taken the perpendicular force. So that's the answer. So L mg by 2. So the net torque will be 0 plus L mg by 2, which is just L mg by 2. Oh, L is nothing but 1. M is also nothing but 1. G is nothing but 10. 2 is 2. So it will be 5 Newton meter. That's the answer. Yep, that's the answer. Very good. Yes, Akash Raj, you should change your DP just like so many others have. And yeah, all the others out here who are regular followers, regular users of this channel, you should show your support, pledge your support by changing your display picture. There is a link in the description box, channel art link. Download that picture, change your YouTube display picture. All right. So that will be like, yeah, you are a V enthusiast. You are a warrior. Yes, you are a Shimon sir student. Yes, you are a Wazim sir student. Yes, you are Shreyas sir student. That's what will happen. Okay. Yep. Yes. When force is perpendicular to R, then the work done is 0. Yeah. Cos 90 will be 0. But torque is not 0. So 5 Newton meter. Moving on to the next question. This question will again be tricky. Many people are going to make a mistake. See, there is a force of 10 Newton acting here. There is a force of 9 Newton acting down. At this point, tangentially, there is a force of 12 Newton acting here. A is 10 centimeter, B is some 25 centimeters. Question is find the net torque. Okay. Now, in order to find the net torque, here is what I'll do. I'll assume one direction as positive, other direction as negative. So let's just take clockwise as positive. There is no harm in taking any direction as positive. So clockwise is positive, anti-clockwise is negative. It's just my sign convention. Okay, that's it. Yes, Akash, everybody can see you. Okay, now, yes, Manpreet, if you have doubt, definitely you can ask. Definitely, if it is relevant, I'll definitely answer it. Now, is this 10 Newton creating clockwise torque or anti-clockwise torque? I think it is creating clockwise torque, because if you visualize it, this 10 Newton will rotate it this way. So obviously it is creating positive torque. This 9 Newton is also creating positive torque because it is rotating clockwise. So yes, this is also positive torque. Make sense? But this 12 Newton is trying to rotate it this way. So it is definitely doing negative. It's giving negative torque. Yep. So positive, positive, negative. That will be helpful for me to write this. Now, what is the torque by 10 Newton? Distance into R cross F. So I hope you can see that clearly, that this is the R over here and the angle is already 90. So it will just be R, which is nothing but 25 centimeters, which is 0.25 meters, into 10 into sine 90. That's the first term. Second term. Again, you can see the second R over here. This is the R. Again, it is perpendicular. So, plus again 0.25 into 9 into sine 90. Why 90? Because it is perpendicular. The last one over here is like this. Now, a lot of people might think the angle between R and F is 60 or 30 degrees, but they are all wrong. Look at it, the angle is still 90 degrees. Many books, many people make this mistake. Look at this. This is a tangent. This is R. So actual angle between R and F is still 90 degrees. So it will be minus because it's negative torque. So R is 0.1 meter into force, which is 12, into sine 90. Did you understand this common silly mistake which many people do? Sir, why do you call multiplication sign as a cross? It's because of the looks. Yeah, because of the looks. Number two, we refer to operations on vectors as cross rather than multiplication. So it's just a specific term which is used for vectors. You do not put dot over there. The dot has a different meaning. That's an operator used for scalar product, and the cross has a different meaning because it is used for vector product. Okay, can we even take anti-clockwise as positive? Definitely you can take. There is no problem in that. Yeah, now just do the math and see what you get. This is sine 90, which is 1. So 10 into 0.25 is 2.5. 9 into 25 is 225. So this will be 2.25. And this will be minus 12. So that will be 1.2. So 2.5 plus 2.25 is 4.75. 4.75 minus 1 is 3.75, minus 0.2 will be 3.55 Newton meter. So that's the net torque. That's the answer. Is that clear, my warriors? This will be very useful for our next class when we will be solving questions on pulleys, and there will be threads pulling from different places, and you have to calculate the torque by the tension. Yes, that's the answer. Very good, Chandan, Roshni, Harita, excellente, Rudresh, Mayank, Dakshin, excellente. Moving forward to the next questions, but before that, let's talk about equilibrium. Because today's topic, we're going to make use of torque, we're going to apply torque for finding and solving different kinds of problems related to equilibrium and toppling. What is the meaning of equilibrium? You all would have done this 110%. If you have not done it, I am really scared about your childhood. Trust me, you would have done this, and probably I can show that to you if I have an eraser and a rubber. I'm not sure whether I have one. Let me see. Okay, yes, I do have it. I used to do this in school. We used to take scales and then we used to take a sharpener. I hope you can see this tiny mini sharpener. I have a sharpener. I still carry a sharpener. I have never used it for the last 2 years, I guess. But still, I carry it. And I have an eraser. I never used it for the last 2 years. It's still intact, I think. And you place it over here and then you try to balance it. Have you ever done that? Look at this. I'm just going to do this live. Oops! Don't fall. Please don't fall. Don't embarrass me. Don't embarrass me in front of all the kids, my lovely warriors. Yes. Let's try to do this. And okay, I can find a balancing point. Oh, beautiful. Oh, this is so beautiful. Look at this. It looks as if it is at the center, but it is actually not. It's slightly towards this side. I'm not sure if you can see it. If you can somehow calculate the distance, you will see that this distance is slightly less. Yeah, this distance is towards the eraser is slightly less, and I have balanced both of them. Isn't it fantastic? So cool. Yep. Yeah. Oh, Roshni still does that. Proud of you, Roshni. Very good. The balancing there. And look at this. I can do that. I hope I don't drop it. Okay. Carefully, let me place these two gentlemen on the table. Okay. Now, what happens is in equilibrium, there is a balancing act, and it happens on a seesaw as well. This is your fulcrum. These are your two loads or two masses. This person has some weight, so he has some force m1g. This person has some other mass, let's say m2g. This person is at a distance r1 from the fulcrum. This person is at a distance r2 from the fulcrum. And at equilibrium, the net torque will be 0. Because if there is torque, then there will be rotation. So at equilibrium, what will happen is the net torque will be 0. So the torques which are anti-clockwise will be balanced by the torques which are clockwise. Or in other words, the total torque will be 0. So if I assume the positive torque to be clockwise, what will happen? The torque which is clockwise is because of number 2, R2 into M2G. This is the torque, positive torque. Minus, why minus? Because this one is creating negative torque, it's anti-clockwise. So minus R1 into M1G. This total torque will be 0. If you shift this term, it will look like this. R2 M2G is equal to R1 M1G. This just says all the torques which are clockwise are being balanced by all the torques which are anti-clockwise. This is a perfect balancing condition. This is a balancing condition. This is a condition for equilibrium. And you will be solving more problems like this right now. But I hope you understood the concept behind balancing objects. The net torque should be 0. Yes, not just that, even the net force will be 0. Okay, because it is at equilibrium. So the net torque and the force all will be 0. Till this point of time, we always used to solve problems where net force was 0. But today, we are going to solve problems where net torque will be 0. Yeah, I hope this is clear. My God, somebody has lost a lot of erasers. Roshni, I hope after today's lectures, you're not going to lose erasers. You're going to gain lots of erasers. I'm not sure what you're going to do with it, but yes, you're going to win a lot of erasers. All right. Hello, Malvika R. Welcome aboard. Great. Just keep the eraser at one end and hit the other end. Yes, Chandan, I have done that. It's fun. Yeah, and we used to do all sorts of things. We used to hit, and then we used to do projectile motion like a catapult. And we used to see like how far can one person throw this rubber. And we used to sit, like our class had this division, and all the guys used to sit on one side and all the girls used to sit on the other side. And then we used to do this, and these erasers used to always fall on the girls' side, and we used to get blasted. Yeah, we used to stand outside the class every time. Yeah, very bad. Oh, this was a secret, not to tell anyone. Bye. Okay, let's solve some questions. Shown in the figure is a rigid uniform 1 meter long rod AB which is held horizontally by two strings which are tied to the ends and attached to the ceiling. The rod is of some mass m and has mass 2m attached over here. Okay, question is, what is the tension in the string A? What is the tension in the string A? Kushagar saying flirting technique. Oops, is it Kushagar? Okay, Kushagar. Now I know how Kushagar flirts with girls. He catapults rubbers into the place where girls are there, and the place where the girl is, that's where it's supposed to land, and that's the way Kushagar Sharma flirts with girls. Very interesting technique. I got to know this now. Guys, note it. 10 ways of flirting with girls. Yeah, I think we have one way. Okay, crazy. Okay, projectile motion. Let's do this question, guys. Let's do this. So we have to find the tension over here. Now you might be like, sir, it is easy. I know what to do. This is T1. Let's say this is T2. Why are they different tensions? Because there is a asymmetric distribution of the mass. There is a asymmetric distribution of the mass. More mass is there, so tensions will be obviously unequal. The rod itself has a mass, what is it? Yes, rod's mass is m. So the rod's mass will be at the center. So I should show mg from the center of mass. That's why I taught you the chapter of center of mass in the first place. Correct? Similarly, think about it. This 2m will also have its own weight. So there will be a 2 mg force over here. Even if you try to write this equation, net force is 0, what are you going to get? Upward force, which is T1 plus T2, will be balanced by mg plus 2 mg. That will just give me 3 mg on RHS, but I will not be able to calculate individual values of T1 and T2. So I think I need something else to calculate the individual values of T1 and T2, and that will come from torque. So the torque should be 0. Torque should be 0, and I want to find T1. I'm going to do a very smart move. I'm going to measure the torque about a very smartly chosen point. If you are smart enough, which point will you choose to measure the torque? Will it be A? Will it be 50? Will it be 75? Or will it be B? Remember, you have to find T1. Will you choose to find the torque about point A, 50, 75 or point B? Let me know. Come on, think about it. Okay, Aishwarya has already given some answer. Let's see if it is correct or wrong. Okay, most of you are saying A, some of you are saying 50. I'll tell you what. No, you're not going to choose 50 or A. In fact, you're going to choose B. Like, what the hell? See what happens. If you choose net torque about point B as 0, because it is in equilibrium, then the torque of tension 2 becomes 0. Why? Because about this point, the force is passing through this axis. So the torque of T2 will become 0. Is that making sense? So the torque of tension 2 is 0. This is of tension 2 because it is passing through that point. This 2 mg is creating a negative torque or anti-clockwise torque, I can say. This distance is 25 centimeters or 0.25 meters. So minus 0.25 into mg because it is anti-clockwise. That's why the negative sign. This mg is at a distance of 50 centimeters, which is minus 0.5 into mg, again because it is anti-clockwise. Lastly, this distance is 100 centimeters or 1 meter, and this tension 1 is creating clockwise torque. You can see this will create clockwise torque. So plus distance is 1 meter into T1, so it is clockwise. This total sum should be 0. 0.25. Oh, wait a minute. This was 2 mg, my bad. This was 2 mg. Yes, this was 2 mg. So 0.25 into 2 mg. Now 0.25 into 2 is 0.5. Minus 0.5 minus 0.5 is minus 1 times of mg plus 1 times of T1 is 0. 1 just goes. T1 will just be equal to mg, guys. So is mg there somewhere? Yes, it is there. Option D should be correct. And I think some of you were actually correct. Very good. Excellent. Hello Aisha, welcome back. You should set the time according to IST, I guess. I think the timings differ everywhere. Yep, it is 1 mg. Correcto. Namaskar Satyam Kumar Jha. Main aa gaya. Aaj jao Satyam. Okay, so beautiful question on torques. And from this, you can also find T2. Think T1 plus T2 is 3 mg, right? So from this, you can substitute the value of T1 over here. So mg plus T2 is 3 mg. So T2 will be 2 mg. So this tension is more, this tension is less. Got it? In case it was asked. Priya, I think it will be after February only. Okay, it won't be before that. Let's solve this another question. It's a beautiful question. Hi Akshay, welcome. Yes, Shashti, I changed it to 2 mg. Yep, I changed it to 2 mg. I have done that. Sundar, vanakam bacha. Vanakam. Yeah, I hope the situation today is much better in Chennai and surrounding areas. I hope the floods are receding. I saw some terrible pictures of Chennai airport, and it was like, it was not an airport, it was just a seaport or something. It was crazy. Okay, so let's solve this question. Here you have a rod. This is the ledge. Okay, in case you are wondering what is the ledge, this is basically a short, recess inside in the wall. So that's a ledge. Okay, so this is a ledge. Okay, this is your rod, and this is your string, and this is your mass. The rod's mass is 35 grams. The mass supported on the other side is 65 kg. There's a string. The question is, find the tension in the cable. Let's do this question. It's very easy. First of all, think what will be the different kinds of forces acting on this rod. Number one is the weight of this mass, which will be 65 G. 65 is the mass, into G will give me the weight. The rod itself has its own mass. So obviously there will be 35 G, like you can see over here, right over here. Apart from that, there will be also a tension force because of the string. So I will put T. And there will be a reaction force. I'll just call it as R, from this edge on which it is supported. Because it is supported at that edge, it is being pressed down, it is being pushed here. So obviously the reaction also might be at some angle which I do not know. Now the thing is, we have to figure out what is the tension. I do not know what is R. I do not know what angle R makes. I think I'll try to solve this question via, torques. Think closely enough, think smartly enough, and figure out where will you choose the point to find the net torque. Think carefully. JEE, the joint entrance examination, it's your one-stop destination for getting any or most of the colleges in India. Yeah, so joint entrance examination conducted by the HRD ministry, the government, for getting admission into all the top-notch colleges or all colleges across India. Okay, so I think I will choose this point. Why? Because the moment I choose this point, what happens? This R will pass through that point. The torque created by this R will be 0. So if I do this, the net torque about the ledge, that should be 0 because it is in equilibrium. So then the torque by R plus torque by 35 mass, the torque by 65 mass, and the torque by tension, this should be 0. Out of that, this torque will be 0 because this force is passing through that point. 35 kg. Where is 35 kg? Look at it carefully. This is at this distance. This is perpendicular. What is this distance? If this is L, this is L by 2. Make sense? This is L by 2. So that will be L by 2 into force R cross F into 35G. In case you are wondering what is the angle between R and F, it is already 90 degrees. Look at it, R is there, F is down, R cross F, that will be sine 90. I'm just putting sine 90 for your understanding. 65 kg is also creating clockwise torque. So I'm just going to make it plus. The distance from this point to this point is L. So L into 65G into again sine 90 degrees. The only thing remaining is this tension. This tension will have two components. Think about it carefully again. One component will be here, the other component will be here. This component will be T sine 30 and this component will be T cos 30. Which component will create torque? Put the answers in the chat box right now. Come on, think. Very good, Khushgar. Yes, you will take the torque from the ledge, correcto. Oh my god, Mayank, 9th grade student attending this class. Good, proud of you, and keep attending. Keep it going. Hi, Molesh, you're joining in late. Yes, the sine component, cos component will not create any torque. So, and that torque will be also negative. Why? This tension will try to rotate it this way. Just visualize it. Just hold a pen or a pencil and see how does it make it move about this point. It will make it move anti-clockwise. That's the easiest way to figure out the directions. So minus L into T sine 30. That's it. So just do the math. Oh, by the way, this should be equal to 0. So L goes. So 35G by 2, okay, plus 65G. Take the minus sign over the other side. It will be T sine 30 is half. Okay, so multiply by 2 on all the sides. So 35G plus 65 into 2 is 130G is equal to T. So T will be equal to 160. Yeah, 165G. So this will be nothing but 1650 Newton. Is that clear, my warriors? Is that clear, my warriors? Yep. T cos theta results in instability, rather it just tries to push it against the wall. That's it. Yep, correct the action. I hope this is clear. Okay, so that's how we have found out tension. No equation of forces, only equation of torque, and that too just one equation. Okay, chalo, let's move on to the next one, and that is toppling, and this is going to be real fun. Okay, Sai Ram Srinivas, last year we did a flash series because we started our channel in October. So we wanted to complete the syllabus, you know, for 11th and 12th. So that's why we had the flash series. But this year we started everything back in April and May and June. So we had a lot of time. That's why we are doing this long-term series, not the short-term series. In case you want the short lectures, then you can watch flash. But I would suggest technically you should watch the long-term series classes which we are conducting this year, which is the Nurture series and the Pathfinder series. Okay, bacha? Okay. So cars education, you can just go back a little bit and rewind and watch it again. I hope that will be better and that will be much more fruitful. Okay. Now, here is the next thing. For toppling, the criteria is again similar to equilibrium. When do things topple? Things topple when the equilibrium is disturbed. Just before toppling, what happens is every force is balanced. All the torques are balanced. But just when it topples, then some unbalance is created. Some force becomes less or some force becomes more. And that's when the equilibrium is disturbed and it begins to topple. So whenever you see toppling problems, think of it like equilibrium problems. So what is toppling at the end of the day? Toppling is basically problems of equilibrium, and that also means net force is 0 and net torque is 0. If any one of these forces or these torques change, then what happens? Then there is no equilibrium and that creates toppling. That creates toppling. Let's think of an example for solving this. Okay, so just imagine you have an inclined plane. There is a lot of friction. Okay, there is a lot of friction. You have a block like this. There is this angle. Okay, there is this angle theta. You keep a box. You slowly increase the inclination. You will see there will be an inclined angle at which, you know, the box will topple. You can definitely try this at home. It's very easy. I can show this to you with a bottle. And with the bottle, the angle is very less. So right now the bottle is on an inclination of 0 degrees. I slowly increase the inclination angle. Oh my God, I'm scared. Yeah, there it goes. It topples. Hardly for 5-10 degrees. But if I had a much smaller object, I don't know, I don't have a smaller object right now over here, but yes, if I had a much smaller object, then it will topple at a much larger angle. So, you know, that angle at which it topples varies depending on the geometry of the object. So let's see how to do this. Oh my God, memes wala has kicked his friend and he toppled. We can find that out. We'll solve a problem like this. So toppling means you just, you might have seen this. Some person is walking and suddenly you put your leg in the front. That's it. The person falls. So that is basically topple. You fall off and you take the support of a fulcrum, or you fall over a point or an edge. So that's toppling. Now we can see what happens when it is just about to topple. When it is just about to topple. Okay, let me just draw the diagram. Okay, this is that box over here, something like this. This is that box. This is that critical angle. Let's say it is theta C, critical angle. What would be happening? What would be happening is, you know, the normal force which is there. This is that normal force. This normal force will start shifting more and more towards the edge. Why will it shift towards the edge? Because when you increase the inclination, more pressure is there on the right side. The left side is as if trying to lift off. Picturize yourself standing on an inclination. Slowly the inclination increases. You can feel the pressure on your right side and the left foot just coming off. So that means the contact force will shift towards the left side. That's what will happen. That's what will happen. And eventually, when it is just about to topple, the normal force cannot find a place to shift further. It has reached the edge. normal force obviously cannot go outside the box. So the normal force will come over here and it will just topple over this edge. That's what happens. Are you getting a feel of this? Normal will not become zero, just that the normal will come towards the edge. Understand that. Okay, so that's how you are going to solve some problems now. So whenever things topple, you will see something will shift. One of the forces like normal, etc. will shift and it will topple, and if you increase the angle beyond it, that's it. It is just going to fall off. And you will see exactly when it is about to topple, the mg force will be passing through the edge. Mg force will be passing through the edge, because after this angle, the mg force will shift here. Mg force will go outside and that mg will create a torque about this edge. Think about it. The mg force here, then that mg force will create a torque and this box will topple over. But when mg is passing through this point, it cannot create any torque. The moment it goes here, it will create a torque. If it is here, then it will be supported by normal. That's what is happening. Yep. If normal is zero, yes, it loses contact. Toppling is different from losing contact. Understand that. Okay, let's solve some questions based on toppling. Here we have the first question on your screen. Hi Jacob, welcome aboard. Will it not slide? Oh Srishti, in that previous problem I just assumed the friction is large enough to prevent any kind of slipping, because I wanted to focus my attention on toppling alone. But the next problem is based on toppling and slipping both. You will see how to solve those kind of questions as well. Yes. So let's solve this question, and what do we have? We have a box, the center of mass is here, you apply a force and there is a lot of friction. There is a lot of friction, you can see that. There is sufficient friction so that the block does not slide. The question is, find the minimum force required for the block to topple. Whenever such a question is asked, think what they mean is, it is just about to topple. And when it is just about to topple, obviously it is in equilibrium. It is in equilibrium. Okay. And if it is in equilibrium, what does it mean? That the net torque is still zero. It has not yet become non-zero number where it starts rotating. It's still zero. Any unbalance, it will start toppling. So what will happen? Draw the FBD. Which edge will it topple about? I think when you apply the force, the left side will lift, the right side will be pushed against, and it will topple about this edge. So there will be only one point of contact. When it is just about to topple, do you realize the normal force would have shifted here, and this is how the normal force is going to look like? Think about it. Do you see that? The normal force has shifted towards the right side, and it is just passing about the edge, because all the other points have just about they have lost contact, and any more unbalance is going to topple it over like that. Okay, friction at that point will be here. So this is friction at that point. This F force is obviously over here, and what else? mg is also over here. Okay, so this is mg. Now the net torque is zero. That means torque of mg plus torque of friction plus torque of normal plus torque of that external force should be zero. What is the torque of mg? Do you see mg force is technically at this distance? This is the r cross f wala r. This is the r for that mg force. What is this r? If this is L by 2. So r for mg is L by 2, and you can see mg is creating anti-clockwise torque. How did I see that? Just fix your finger or pen over here and see what will this mg do. This mg will try to rotate it like this, which is anti-clockwise. So I'll just create negative torque because it is anti-clockwise. L by 2 is the r into mg, and they are at 90 degrees. So sine 90. Make sense? You can see r and f are at 90 degrees. Great. What about friction? Guys, friction is passing through point O, so no torque. So plus 0. That's it. Friction is just passing through that point. And the same story applies for normal, because normal is also passing through that point, so 0 torque. That force is acting, you can see. What is the R for that particular point? This is that R, because that force is at a distance of L. You can see that force is at a distance of L from that point. Yep. So that will again create a positive or a clockwise torque. Just get the feel. This is the point, this is the force. This force will try to rotate it like this. It will try to rotate it like this. So clockwise torque. So plus distance is L, force is F, angle between force and R is 90 degrees. So sine 90 again is equal to 0. Is that clear? Take this guy on the other side. Sine 90 is 1 anyways. So LF is equal to L by 2 mg. LL goes. So F is equal to mg divided by 2. That's the answer, which is option C. Done, done, are done. So Aisha, students basically prepare for JEE via coaching, via books, via mentors, and if you are doing self-preparation, then the best thing is to do it via YouTube and buy the recommended books and start solving problems and join some test series. But usually, because the highly competitive nature of the examination, students join a coaching and get mentored with experienced teachers and join the test series, solve the assignments, attend regular doubt sessions, and the regular classes as such. That's what we do. Okay, so that's a beautiful problem. Now let's solve another question coming up on your screen. Now this has both slipping and toppling. This says a force is applied on the block as shown. We have to find whether it topples first or whether it slides first. Friction coefficient is given. Interesting question. So let's draw the FBD first. This force is applied. I think this is slightly misleading. This was supposed to be here. Okay, I'll just show it over here. This force was supposed to be here. Just ignore this. Okay, so this force is acting here at a height of 3a by 4. The base is A. That means the weight will be acting exactly from the center of mass, which is nothing but mg. And when it is about to topple, all these points will lose contact. Same story repeated. This will be normal and friction will be somewhere like this. This is how it will be. If you want to find the force required for it to topple, same story repeated. The net torque about point B will be 0. So torque of force plus torque of friction plus torque of normal plus torque of mg will be nothing but 0. You can see the torque of that force will be this distance into F. That distance is 3a by 4. This is for toppling. Okay, this is for toppling. I'm just trying to do it. 3a by 4 into F. Friction will not give any torque because it is passing through that point. Normal will also not give any torque because it is passing through that point B. mg is going to create anti-clockwise torque. This distance will be a by 2 and force is just mg. So minus a by 2 into mg will be 0. Now just rearrange it. Just take this guy on the other side. So 3a by 4 into F will be a by 2 into mg. See what and all will get cancelled. This 2 and this 4, 2. So eventually you will get, oh by the way, even this a will get cancelled. Okay, so I'm just going to be left with F is equal to 3, F is equal to 2 mg by 3, which is like 0.67 mg. So this is the force required for it to topple. This is the force required for it to topple. So, because I've balanced the torques. Now, what we are going to do, we are going to find out what is the force required for it to slide. Slide means linear motion, translatory motion. Remember Newton's laws. Let's do this on this side. Net force is still 0. This is for sliding. We are trying to solve the problem. In the x direction, when this force is just equal to the maximum frictional force, that's when it will be just on the verge of sliding. So when it is on the verge of sliding, this force will be just equal to Fs max, the maximum limiting static friction. You have studied this in frictional chapter, and this is mu into n. And what is n? The normal will be equal to mg force. And what is mu? Is mu given? Yes, it is 0.5. So 0.5 mg. So this is the force required for it to slide. Which one is more? Sliding force or toppling force? Quickly tell me in the answer. Dravid is saying topples first. Okay, let's see whether you are correct or wrong. This is the force required for it to slide. This is the force required for it to topple. Which force is more? Obviously the toppling force is more. So visualize this. You slowly apply the force. Increase it, increase it, increase it, increasing. Which condition will be met first? If you slowly increase the force or the push, which condition will be met first? Toppling condition or sliding condition? Obviously sliding condition, because sliding force is less, toppling force is more. So hence when you slowly increase the force, it will first slide. Only when you increase the force further, then will it topple. So hence it slides first and then it topples. Oh my god, is there, I don't know, depends on when you have seen me. Some students say that I have gained weight as compared to the last few months because I have been eating a lot of sweets thanks to no lockdown. Yes, that's the answer. First slides. Great. I have an interesting thing. I can show you maybe on Sunday. Okay, maybe on Sunday. Yeah, there is going to be an interesting thing on Sunday. Yes, we'll see what it is. Okay, especially for 11th standard students. What is it going to be? Let's see. It's Children's Day. Something special should come up. Yeah, let's see what it is. Okay. Meanwhile, let's move to the next question. And the next question is the best question of today's session, and it's again got to do with toppling of vehicles around a car, around a turn. Yeah. Dhanush, you should hit the bell icon down there. In case you haven't subscribed, hit the subscribe and hit the bell icon and say notify all classes and join the Telegram group link. And yeah, if you're already here and subscribed, yeah, I hope you have also hit the like button down there. Double deckers are considered to be very unstable because of high center of gravity. Sports cars are considered to be very stable because of low center of gravity. SUVs like Fortuner, yeah, or Endeavour, everybody knows these cars. In case you do not know that, yeah, please Google it. Okay, very famous popular cars. They have high center of gravity, so they might be considered more unstable as compared to a low ground clearance, a smaller car which is flatter, broader, but smaller center or very less center of gravity. So what is it that topples a vehicle around a corner? So when you turn, there is a pseudo force, which is the centrifugal force, which pushes you out. So if you're turning, you're pushed out, and you can visualize, imagine you yourself taking a turn, let's say going towards your left side. Okay, I am you watching this video. You turn towards the left side. So if you turn towards the left side, answer this question. Which of the tire or feet will lift off the ground first if it has to topple? I am turning towards my left side. I am watching this video right now. If I turn towards the left side, then which of my feet will lift off the ground first? Will it be left feet or will it be right feet? Come on, answer in the chat box right now. Shashti saying left, Suchi saying right. Yes, Shashti, Lamborghini. That song is very nice. I like that song. And a similar version of the song was played in one of the recent movies. Which was it? Shiddat. It was a nice movie. I liked it. Okay, somebody saying left and somebody saying right. Clearly, you are not thinking correct. So, if you turn towards your left, then you will go like that. What is this? This is left side. This is left side. Right field will be pressed more. Think carefully again. Visualize this. If you cannot visualize, please run around the house. Yeah, your parents might think you are crazy, but just run around the hall. Just take a left turn and come and see what it is for yourself. Why should I convince you? You convince yourself. You convince yourself. When you take a turn towards the left, you go like that. Your left feet will come up, right feet will be pressed. Yes, think about it. Right feet will be pressed, left feet will come out. And that's what we are going to do. So there is a car and it is turning. Okay, this is the back view of that car. and it is turning around a curve. So this is your curve, something like this, and the radius of curvature is r. Center of mass is at height h. The wheelbase is 2l. That means the distance between the two wheels from the backside is 2l. The question is, what's the maximum speed at which the car can turn without it toppling? So that's the maximum speed that we have to find so that it does not topple. Okay, Maruti 800. I don't know which car model is this, but it looks to me like a Skoda Rapid. Yeah, the tail lights, and especially the more like a Skoda or a Vento. Yeah, I don't know. If you're good at cars, probably you can guess it. Okay, anyways, that's not the point over here. Let's try to solve the question. So in the non-inertial frame, in the rotating frame, what I will see, the car is at rest. So I will just say in the rotating non-inertial frame, I will say that the car is at rest, and when it is about to topple at velocity v, then the net torque is still 0, because any further changes in the torque will topple it. So the net torque is still 0 about any point. So to choose the point, let's first draw the free body diagram. First is the weight. The weight will obviously act downwards, which is mg. Fair enough. Next, what we need to do? Oh my god, there's somebody saying Brezza. No, it is not Brezza, it is a sedan for sure. Okay, next is the centrifugal force. Centrifugal force will push it outwards. Centrifugal force will push it outwards, and because you're turning left side, it will go that way. What will be the value of the centrifugal force? It will be mv square by r. So that's the centrifugal force. Make sense? Next, there will be friction, but before that, let's draw normal. I just told you, if you are turning towards the left tire will come up first. So when it is just about to topple at speed v, net torque is 0 and normal force on the left tire will be 0, because this tire would have just lost contact. So there is no normal here, but there is normal at this place. So this normal has just gone, just lost contact, because it is toppling like this. It's toppling like that. When you turn left, it will topple like that. This place, this tire would have just lost contact. That's why that normal is 0. Great. Now, what do we do next? Friction. Where is friction? Obviously, there is no contact here. So no friction. So friction, if at all present, will be over here. That's it. So net torque is 0. That means torque of normal plus torque of friction plus torque of mg plus torque of the centrifugal force will be 0. What is that? Oh, which point am I choosing? I think I will choose this point. Isn't it a smart move to choose this point? Why is it a smart move to choose this point to measure the torque? Because I do not know F, I do not know N. So the moment I choose this point, N and F are passing through that point, and that makes their torque 0. That will make the calculations a little bit easy. It looks great. Okay, so the torque of normal is 0, torque of friction is also 0, mg is at a distance of L. You can see that. Mg from this point is at a distance of L. So this is the R and this is perpendicular. So when you do R cross F, oh, by the way, what kind of torque is this? Mg is creating anti-clockwise torque. Look at this, mg about this point is creating anti-clockwise torque, so that means negative. So I should put a minus sign. This distance is L, force is mg. That's it. That's done with the torque of mg. Centrifugal force, look at that. Centrifugal force is at this distance, which is perpendicular, and this distance is nothing but h. So R over there is nothing but h, and the force is nothing but mv square by r. And is it positive or negative? Well, that also we can figure out. About this point, this force will try to rotate it like this, which is clockwise. So I'll take it as positive. Great. Move this guy on the other side. So H m v square by r is equal to L m g. So many things may get cancelled, like m and m. That's it. Okay. So I want velocity. So move r there, h below. So v square will be L r g by, h. So therefore the velocity will be root of L r g by h. That's your final answer. Done, done, done. So that's the maximum speed. Is centripetal and centrifugal force equal? Zero. Centripetal and centrifugal are two different kinds of forces. Number one. Number two, they are in two different frames. Number three, understand, centripetal is not actually a force. It's a name given to a set of forces along the radius towards the center. And centrifugal is the pseudo force which acts in a non-inertial frame, which is always outwards. So though most of the times you see it equal, but you should not use the word that they are equal, because you will never get these two forces together. Okay, so that's the reason why we do not assume them to be equal, because when you have centripetal, that means you are on the ground frame. When you get centrifugal, you are in the rotating frame. So you don't have that centripetal force. So that's the reason why we don't equate it. Yep, that's a wrong thing, Siva Prabha. Centripetal and centrifugal force never cancel out each other. So please watch my second class of circular motion, which is dynamics of circular motion, where I have explained in detail what is centripetal and what is centrifugal force. Please watch it. It will clear out all the notions and misconceptions which you might have about centripetal and centrifugal force. It's a wrong thing. Centripetal force is not mv square by r. Centripetal force comes out to be mv square by r, but centripetal force is a sum of different forces, tension, normal, etc. So it's wrong to say the formulas are same and they cancel out, sir. One is inward, one is outward. That is completely wrong. Please take it outside your head. Yeah, please unlearn these concepts. Learn the actual concepts. Please watch my second class, first class of circular motion. Do not remember these things. Yep. So they act on, they both act into different frames of reference. If this is there, that is not there. If this is there, that is not there. So don't confuse the two. Yes, Suchi, it is correct. No, Suchi, my bad. It's not correct what you're saying. They act on two different bodies. No, they act on the same body, but in spite of that, they are in two different frames. In this frame, centripetal is there. In the other frame, centrifugal is there. So even though they act on same body, because they are present in two different scenarios, so they don't act simultaneously. Hence, they won't cancel. I hope that is clear. Yeah. Okay. Why am I taking torque along mg as negative? There is no harm in taking torque along mg as positive. See, in this problem, I have taken clockwise as positive. If somebody chooses, sir, anti-clockwise is positive, you will still get the same answer. Instead of this minus, you will get plus. Instead of this plus, you will get minus. At the end of the day, you will still get the same answer. So it's a matter of convention. So what I have done over here is just a matter of convention. Any student can choose any convention. It's up to him or her. Okay, is that clear, my bachalo? What is the difference between loss of contact from surface and toppling? Harita, think about this. There is a pandu. Okay, there is a pandu. And somebody lifts that pandu. Okay, if you lift that pandu, what will happen? Pandu will lose contact from the surface. Make sense? So that is loss of contact from the surface. But somebody kicks pandu and pandu's one leg goes in the air and he topples like this. This is toppling. He has still lost contact from one of the foot, not both the feet. So this is lifting and losing contact entirely. This is not toppling. This is toppling, where you rotate about an edge or a point or an axis. That's what it is. I hope that is clear. Okay, so a lot of interesting questions you are asking, and I'm really proud of you, my warriors, for asking such questions. Keep it up. Keep it up. That's what I'm here for. RLG by H. Yes, that's the answer. Last theorem on your screen. Last theorem on your screen, and this is going to be very important. Not many institutes teach this. Yep. DC, sorry bacha, you will have to do it in your pants. Sorry. Everybody please close your nose. DC has an urgent natural work. It's okay. You should never stop. Yeah. You can take this. You can take the mobile in the toilet. By the way, DC. Yeah. It's allowed. Nobody's going to watch. You can watch me. We can't watch you. Thankfully. Okay. Let's do this. The theorem of torque when the net force is 0. It's an amazing theorem. Okay. So, okay. Uday has closed. Uday, I hope you are alive. Don't close it fully, and I hope you have opened your mouth. Okay. So, what do we have? Here, whenever the net force is 0, there is an interesting thing which comes out. So, net force is 0. That means, let's say this is one point where there is, let's say, some force like, okay, let me just draw it something like this. This is F1. Let's say this is F2. And let's say this is Fn. So, n points are there. P and Q are some random points. From point P, this F1 is at a distance of R1, this F2 is at a distance of R2, Fn is at a distance of Rn. So this is Rn, the position vector of the nth force. But similarly from point Q, the same force is going to be at a different distance. I'm going to call it capital R1, capital R2, and similarly capital Rn. P and Q themselves are separated by some distance. So let's call that separation, let's call that separation as D vector. That's the distance of separation. Fair enough? So what are these points? These are some points on which F1, F2, F3, F4 are acting. P and Q are some random points about which you are trying to measure the torque. So if I ask you, what is the torque about point P, that net torque about point P, then your answer will be torque due to 1, torque due to 2, torque due to 3, all of them have to be added together. So torque 1 plus torque 2 plus the nth torque. So torque of the first force will be R1 cross F1, similarly R2 cross F2. The last term will be Rn cross Fn. That's it. Very good. Now I'm going to do one smart move. Look at any of the position vectors, let's say R1. Look at this triangle and you will see one very interesting thing happening. This is R1 vector, this is your D vector, and this, okay, this is your capital R1 vector. Do you see one triangle getting formed? This is one vector, this is another vector. The addition of these two vectors is this vector, triangle law of vector addition. So technically over here, what is happening is R1 vector is D vector plus R1 vector. Do you see that? R1 vector is D vector plus R1 vector, and it is true for all other vectors like this. Like, you know, Rn vector, small rn vector is D vector plus capital Rn vector. This plus this gives you this. So it's true everywhere. Exactly. So now what I'm going to do is I'm just going to replace the terms and see what happens. Okay, so this will be equal to R1 is D vector plus R1 vector cross F1, and till the nth term, so D vector plus capital Rn vector cross Fn. Okay, great. Now expanding all of them, so D cross F1, I'll get it here, I'll get D cross F2, D cross F3 everywhere, so I'll have a lot of D cross Fs. So the last term will be D cross Fn. I hope this is fine, everyone. So D cross F1, D cross F2, D cross F3, D cross Fn. The second set of terms will be R1 cross F1, okay. Next term R2 cross F2, R3 cross F3. Last term will be Rn cross Fn. These are the other set of terms. Here D cross F1, D cross F2, you can see D is common. So I can just take D outside. So if I take D outside, it will be D cross F1 plus F2 plus Fn. Is that right? I've just taken D outside. And what is this? R1 cross F1. R1 cross F1 is torque about point 1. but this is a different torque about different point. This is all about point Q. So think about it. Technically speaking, this is nothing but the total torque about point Q. Is that making sense? Capital R is measured from point Q, small r is measured from point small p. Yeah. Why is it not added in order? It is added in order only, Suchi Mama. I just skipped one step. I could have done that. I mean, I could have done this. D cross F1 plus plus R1 cross F1. Next term will be D cross F2 plus what is it? R2 cross F2. I could have done that, and then I could have chosen the same terms together. Okay, but I have skipped that step. I hope that is making sense. Okay, so this is torque about point Q, and what is this? Clearly, net force is 0. What is the meaning of net force is 0? F1, F2, F3 together is 0. So that means this is D cross 0 plus torque about point Q. So eventually this will become torque about point Q only, and this is torque about point P. Very, very important theorem. So this is only true when net force is 0. Only when net force is 0, then you measure the torque about any goddamn point. It's always going to come out to be same. Very, very important theorem. Okay, so what if the front and back have different axes in terms of length in the last question? So Janeshwar, then you have to consider those independent axes. It will become slightly more complicated, but here we assume that both the front and the back wheels have the same almost center of curvature and all of that. Okay, how to go through the tough topics of physics easily, sir? Please tell me. Start with the easy ones, understand the concepts, question it, solve it via different methods, then go backwards, try elimination, try substitution, discuss it with friends, and then go to higher level problems. Always go from smaller to bigger problems. And whenever you see any phenomena, try to explain it physics wise, chemistry wise, maths wise. And always think about laws as rules of the game of the world. So our world has some rules. So what you are learning in physics is just nothing but the rule book. Like when you learn a game, you are told the rules. This is the rule, this is the rule. So in physics, you are just learning the rules. To apply the rules, you need mathematics. So it's just about learning those rules of how the world works and applying those equations to make sure you understand what is going to happen in that given situation or scenario. Okay, so that's a beautiful theorem for all of you. Torque about any point is same when the net force is 0. Then the torque, oops, sorry, this statement is wrong. I'll just edit it. This is supposed to be, if the net force is 0, I'll just change it right over here so that when you're watching the video it is clear. Then the torque about any point is same. Okay, it is same. Keep this in mind. Very, very important. Okay, so these are your two homework questions. This is your first homework question. I'll be announcing the names in the next class, just like I did it at the start of the class today. So this is your first homework question. Put the answers in the comment section. This is your second homework question on torque. And where will you get the solutions? On our Telegram channel. And if you want to take up Vedantu Pro subscription, and I'll give you many reasons for doing that. First reason is obviously live online coaching, and not just that, you also will get the replays. Then you get tests, assignments, and your Tattva module, which is your book, which Vedantu gives you, both hard copy and soft copy. Not just that, you will get report cards, you will get parent-teacher meetings, you will have strategy sessions, and you will have guidance sessions, you will have interactive sessions, apart from continuous feedback from teachers and personal teachers, and all the staff at Vedantu will always tell you what is that you should do, or you will have sessions where you will be getting personal feedback on how you can improve on your weak points. And then you also have teachers just like me, lots and lots of experienced teachers with 10 years, 20 years plus experience, all IITians and IITians and from top-notch institutes and colleges. And you have the option to learn in English along with you have my micro course. So Capto's micro courses are also available, like the derivation one. You have my derivation micro course, you have my HCV micro course, you have my problem solving micro course, you also have my Erodo, the toughest questions for Olympiads and JEE Mains and Advanced. You have all these micro courses of mine along with other teachers' micro courses. So if you are interested, what you need to do is, as you are watching this video, just go to the description box and click on this link, JEE 2 years, avail all exciting Vedantu courses, and you will see you will get not only this year's course, you will also get the revision course plus the 12th standard course plus the mock test, the test series till your final JEE Advanced examination. It also includes KVPY preparation and board preparation together. Okay, it's all inclusive. You will get 3 packages. The Lite includes everything that I told you. In the classic version, you get the additional facility of solving doubts on the mobile app, and in the Plus version, you get additional mentorship if you need so. One-to-one correspondence. And you can see the prices are very affordable for 2 years. 54,000 for the Lite version, 60,000 for the classic version, and 97,000 for the Plus version. Okay, so even the highest version is half the price, or not even half, 1/4 the price of your regular coaching. I know regular coaching for 2 years will be around 3 to 4 lakhs, and this is almost like 1/3, 1/4 the price. So even if you go for the Lite version, you can see you can try it out for 15 days. You get additional 15 days for free. So try for 15 days plus you get additional 15 days. And what do you need to do? You need to use my coupon code SHHPRO. You can also recommend it to your friends and cousins in case they are interested. Like you can see, also get 10% off using my coupon code. So that's another reason why you should use that. Okay, so all of this is there in our pro subscription. I'm really hoping that you will join this very soon, because all the toppers are our pro users, and you can see there are almost like 6% of the students from Vedantu who will be joining, or rather the total pool of IITians this year, you will see 6% of them will be from Vedantu alone. So hoping forward to see you all. And if you have loved this session, do not forget to like it and subscribe it and share it with your friends. Recommend this channel, get more friends to this channel as well. Okay, so yes, very true, Chandan. You will get 15 days free after 15 days subscription. That's an offer running right now. Please, when you get time, make a live micro course of yours, Srishti. Definitely, I'll plan something for 11th standards kids as well very soon. But meanwhile, you can watch my recorded ones as well. Bye bye Molesh, bye bye Aishwarya. RS, if you handle JEE examination, board examination gets handled easily because the concepts are same. Number 2, weekly once, keep one day where you practice the back exercises, problems for board examinations. Just keep writing those answers. That's it, blindly. Make a notebook, just write those answers 100 times. That's it, done. You are prepared for boards. You don't need to do anything. Yeah. So Arun Balaji, the droppers batch. There are 2 droppers batches starting. In fact, on 15th of November, there is also a link below. You can choose which batch you want to join, dropper batch or 12th batch or whatever batch. If you choose dropper batch, there is a batch starting this Monday. You can definitely join it, and it's in English medium. Bye bye Roshni, take care. Yes. What is hard copy and soft copy? Siru, this is hard copy. This is the book that you will get. It will be couriered to you. Soft copy means PDF. You will get also the PDF as well as this book when you join the pro subscription for 1 year or more. Okay. Yeah. On YouTube, Arun, I would advise all the droppers to watch the regular long-term batches. Matlab Nurture series and Pathfinder, because there is nothing different that you need to do apart from, if you know the theory, then you can skip it, then watch the problem solving sessions. So that's what I would say, Arun. Plus I would say, Arun, if you're taking a drop, please don't completely depend on YouTube. Take the support of YouTube and join a dropper batch. Don't completely watch on YouTube because you are taking a drop, you are repeating. So I would advise you personally to please join the dropper batch. There are dropper batches starting on 15 November. Don't wait for any more time. But yes, YouTube will help you, but it's very difficult to stay motivated just on YouTube, especially for the dropper students. That's why I recommend you to join a batch. Okay, so bye bye, take care RS, bye bye Mohubugan, have a great time, And I hope you all enjoyed the session. Have a great time and stay safe and stay healthy. Hasta la vista. This was your Capto Shreyas.